All right, I want to take a quick look at the antiderivative of 1 over x. First of all, just look at the graph of y equals 1 over x. Okay, this is the reciprocal function. When x is really small, 1 over x is big. When x is big, 1 over x is small. And likewise on the negative side. Okay, so the graph looks like this. It is an hyperbola. And we know from Calc 1 that the derivative of the natural log of x, why did that just jump over here? Let's move this a little bit. There we go. The derivative of the natural log of x is 1 over x. But the natural log of x, I'm going to draw this in red here. The graph of the natural log of x looks something like this. All right, it turns, well, it never goes horizontal, but it doesn't go up very quickly. Why did that do that? It's got a vertical asymptote here, so the slopes of the tangent lines are very steep and positive, which is why this is very high and positive. That 1 over x, the height of the 1 over x is telling you the slope of the tangent line. As you move further and further to the right here, the slopes are getting less and less, and likewise down here, you get down to almost horizontal tangent lines. The thing about this is only true, the derivative of the natural log of x is 1 over x. The natural log of x only defined for positive values of x. Let me take that back. Natural log of x is defined for negative x's, but you get imaginary outputs, and we don't want to deal with those right now. So we only get real outputs for positive inputs here. What's going on the negative side? Well, it turns out if you look at this other function, which I'll do in, pick a color, any color, purple. Take a look at the natural log of negative x, which graphically looks just like a natural log function, but it flips all these positives to negative and all the negatives to positive. So now this is only defined on the negative side, and it looks like that. Okay, this is y equals natural log of minus x. But if I take the derivative of this, right, this would be 1 over minus x, and then there's a chain rule that says times the derivative of the inside. Well, the derivative of the inside is minus 1. Well, that's just 1 over x. The derivative of the natural log of 1 over x, sorry, the derivative of the natural log is 1 over x. The derivative of the natural log of negative x is 1 over x. Both of these have the same derivative, but they're defined on different domains. The first one was only defined for positive x's. The second one was only defined on negative x's. So what we do is we look at a bigger function that's defined on all the x's, except for 0 still. But if you look at the natural log of the absolute value of x, right, that now encompasses both right-hand side and left-hand side. The thing is, if x is a positive number, the absolute value of x is still x. It doesn't do anything. If x is a negative number, then the absolute value actually multiplies that x by negative 1 to make it positive. That's what this is. So the graph of y equals the natural log of the absolute value of x encompasses both the left-hand side and the right-hand side of this graph. So that when we say the antiderivative of, if f prime of x is 1 over x, then the antiderivative, so the function that it comes from, must be this, plus potentially a constant. I don't know whether x is positive or negative when you say here, because 1 over x is defined for both positive or negative. So when I look at an antiderivative, I've got to get either part here, and I do that by throwing an absolute value sign in there.